Okay, this is the video recording for Unit 2, Chapter 1. In this unit, we were talking in class about, it's all about terminology. So everything we've done so far, well, there are a few things that will be tying into it, but we're going to be talking about functions and relations. So it's going to seem a little odd at first, but you'll get the hang of this. So our goal for this section is to figure out what a function is and then be able to identify it in an ordered pair, a table, a graph, and a mapping diagram. So I'm going to go ahead and have the notes here, so you definitely want to pause this, but I'm going to explain what all this means. So you have 4 different animals here, and you have your input. So if a chicken goes in to, be a slaughterhouse or whatever you want to call it, sorry for the vegetarians, but if chicken goes in the processing machine, then you get chicken nuggets. If a pig goes in, well, you'll probably get the McRib, the fish sticks, and the cow, the steak fingers. Well, if a cow goes in again and it comes out with fish sticks, you'll be like, wait a minute, what's going on? So every input has exactly one output. So our vocabulary here for relation, this is where you want to pause the video and write it down, but it's a relationship between inputs and output values. A function, it's a relation where each input has exactly one output. A relation where each input has exactly one output. And we're going to do some practice with this. So we're going to pause, make sure you write this down. Now, ways to represent a relation. You can do it ordered pairs, to where your 2 and your 5, your first number is your x, your second number is your y, which is your input and which is your output. So when it says where each input exactly pairs with one output, every input, the 2 goes in and gets 5, the 1 goes in and you get a 4, the 0 goes in and the input is 0, the output is 3. Then I put, if you get a 2 and you get a 7, well, that can't happen in the same little machine because you put a 2 in and you got a 5. So the key idea, to be a function, you don't want the x values to repeat. Again, to be a function, you don't want the x values to repeat. So this would be a function, but I was just writing this here to show you how it couldn't be a function if I added in a 2 and a 7. Okay, so another way to represent a relation is the table. So your input is your x and your y is your output. Usually x is always on the top or on the left, depending on how you write your table. So we had like the input of 0 goes to 3. Input of 1 comes out 4. The input is 2. The output is 5. A graph, same thing. If 0, 3, 1, 4, 2, 5, this would be a function. Now, this is a mapping diagram. A mapping diagram is almost like ordered pairs, but it just puts arrows on where it goes. So the 0 is matching up with the 3. So an input is 0, output is 3. The input is 1, the output is 4. The input is 2, the output is 5. So this is a mapping diagram, and this would represent a relation and a function. Okay, now we're going to practice a little bit. We're going to practice on determining if they are functions or not. Now I'm going to cover this up a little bit. So remember how I said the other side, to be a function, you do not want the x value to repeat. So our x values here are -2, -1, 0, and 1. Now, do any of those x terms repeat? No. So that is a function. Every input has exactly one output. Okay. Now here, as you can tell, 4, 8, 6, 4, 5. Notice the 4 goes in as 0 and the 4 goes in as 3. So the input is 4, comes out, output is 0. Input is 4, the output is 3. Well, that can't be possible. Think about a pop machine. You put in 4 quarters and I want a Sprite 0 and I press the Sprite 0 button and it pops out. Great. Well, then I put in 4 quarters again and a Dr. Pepper pops out. Well, no, I want a Sprite 0. So function machine this input is paired with exactly one output. So that is not a function because the 4 has 2 different outputs. Okay, so number 3. Sorry, I'm moving this over. Number 3. Oh, I just covered it. It doesn't matter. Okay, number 3. Notice these 2 are the same. 0, 0, but one's going to 5, one's going to 6. So that's not a function. Number 4. This is where a lot of people kind of messed up in life class. They thought, oh, wait, but if I rewrote these as ordered pairs, -1, 4, 3, 15, 11, 15, if I wrote this, the x value does not repeat. The y value does, and that's perfectly fine. So the x value does not repeat, so that is a function. Okay, 5, 6, 7, and 8. Would you try those real quick before you see the answers? Okay, so number 5, the x value does not repeat, so that's a function. Number 6, be careful, that x value is repeating to all 3 of those, and I went ahead and listed them out. You can see the x value repeat, so that's not a function. Number 7, not a function, because there's a 5 going in as an input, 0 is your output. Go put in 5 again, but you get 10, so that's not a function. And this, -4, -1, 2, and 5, those are x values that do not repeat, so that is a function. Okay, now we've talked about ordered mapping, we've talked about tables, we talked about ordered pairs. The last way to represent a function is through graphing. So we're going to look at a graph, and what we can do here is what we call the vertical line test. A graph represents a function when no vertical line passes through more than one point on the graph. So what I'm doing here is if I just do a vertical line straight down, I only hit one point at a time. This is a function. This one is not a function because if I draw a line here, I hit these 2 points. If I draw a line here, I hit these 2 points. This one here, I can hit this and hit 1 point, that's fine, but anywhere else on the graph, I'm hitting 2. So this is not a function. The reason being, check this out. If you move over here and hit this point, move over here again and hit this point, you are repeating the x value. Okay, so we're determining if it's a function or not, representing what's on the graph. Okay, notice if I do my line, vertical line, it only hits 1 here, but look, it hits 2 there, it hits 2 there. So that's not a function. This one, if I drew a line anywhere on the graph, it only hit 1 point at a time. So that's a function, a vertical line. This one would be a function, vertical line, that would be a function. This one, not a function. So many lines I could draw that are going to hit 2 points. So that's not a function. So that was the notes on 2-1.